This is a demonstration on how to use CMAP to load corrosion mapping data onto a vessel. This helps support the collection of data to, for example, to calculate the coverage. So when the application launches, it'll look something like this. You may need to go to the menu, go Analysis Mode, and switch it into Vessel Mode. If you do that, the software will restart, and you should see a window the same as this. We're not going to create a vessel in this one. We're going to load one that's already been created. So we go to File, Open. If you go to Open, then that'll bring up a UI dialog where you CD to where the project file is. But once you've opened it once, it will add it to your history menu. So in this case, I'm going to open this one here, which has already been created. So we load it up. We can have a quick look at it in 3D just to make sure it sort of looks the way it should do. And we see here the vessel. We can, in theory, edit the nozzles if required, but that will be another video. So what I'm going to show here, close this down. So I select Strake 1. What I'm going to show here is loading. I'm going to load CSV files. We could load the scan files directly. So we click on Files, click on Add Scan, and then I'm going to go here. So these are a whole pile of dummy scans that I've created. So I'm going to select the ones for Strake 1. So if these were automated scans, then the positions would be extracted from the file directly. But if they're manual scans, then the positions aren't in the files. So these will load in a few seconds, hopefully. Okay, so they've all loaded, and by default it doesn't know the positions. So if you follow the file name and convention that is specified here, so a name, and then actual start and finish separated by a dash, and then circum 0 finish separated by a dash. This one is datumed around at the bottom of the dome. If we right click on here, this gives us a menu with lots of options. One of the ones is positions to extract from the file name. So we're going to extract all the positions from the file name, and that will convert all these numbers into the actual and circum positions, as you can see here. And then if we click on the little corrosion map icon up here, then it will draw the corrosion map on the strake. Now this looks sort of a little bit low resolution, so you can use this slider here to give us the full resolution of the corrosion map, and we can toggle on the color bar to see. So that's a strake where we get virtually 100% coverage. We can add from the coverage from the menu here, 2D, include coverage percentage and title if it's not already on, and then we can see here we have 100% coverage for this strake. Yay, that's very good. However, we're going to look at another strake now. So strake 2, same idea, go to the files menu, add the files. This time we're going to look for strake 2 files. Here I have indicated sort of poor access, so not all the areas have data. So again, the files will load relatively quickly. The positions again are not set correctly, so we can right click on this, positions, extract from file name, and it will again extract them all. And we have a variety of different scans in different positions, as we see here. So we can see there's a lot of areas that we don't have any data, and here you can see the coverage is 74%. So that's sort of given being able to monitor what sort of coverage we're getting as we're collecting the data. If any of these scans, so that you can here we can if any of the positions are wrong, there's a number of things that you can do. So let's just sort of hide all of them to make it a little bit easier. That turns them all off, and we can look at one individually. So we uncheck hide, and you can see this one will draw there. So if the orientation from left to right is wrong, then it's very easy. You just sort of change the numbers from 500 to 0. It would indicate that obviously the file name is wrong, and we'll see that it's switched around from where it was before. You can also put a rotation angle in, say 90 degrees, if it's the wrong way around, and again, similar sort of thing. So you get here. So so far. There's lots of other options, but I'm not going to cover too many in detail just now. For the domes, that's slightly different, the way that we sort of recommend that you collect the data for the domes. If I just turn the grid on quickly, here you'll see that there is two different ways of collecting data for the domes. In the center you have a XY sort of center datum that is the center, so positive X, positive Y. And then there is around the knuckle, so that at some point, sort of usually a weld on the vessel, you'll start collecting data in polar coordinates. So you would think of an angle going round and the radius. So, but in essence, it's the same idea. We're going to click on Files. We can add some scans, and from the Dome North, we will add all the scans that we have for the Dome North. So we have some, you can see here with a name. Some are Dome North, sort of X and Y. There's also a M for minus in front of it, so that the algorithm can work out where the positions are. This isn't mandatory, but it makes your life a hell of a lot easier if you follow this convention. And then there's the Dome North Knuckle, which has angles, so from 0 to what would be 360, but 0 to 45 in this case, and then the radial positions going from one radius to the next radius. So if we click on Open all of them, it will load all of them. And there we go. We have to tell, the next thing we have to do is extract the position from the file name again. And it will attempt to do it. If it fails on any of them, then you will end up with sort of these would remain 0101, for example, as they were by default. So if we now need to tell the knuckle ones, we select on them and say is knuckle, right click menu, is knuckle, set selected as knuckle, and that will then draw them on the knuckle. So you now have full coverage, full data processed, and your corrosion map. If we then have a look at our corrosion data in 3D, and that will just pop up in a minute. And we can see here that we have a corrosion map of the strake and the dome. This is normalized between 0.5 and 1 because quite often the domes and the knuckles have different nominals, so the data is presented slightly differently.